What one on the first group of problems do you want to talk about? First group. Anybody, hands. We're using hands today. The first group, the 37th, 44? We have a bid for 44.
Oh, yeah.
44 says 5 to the x plus 2 equals 7 to the x minus 2. There are many different ways to do this, many different ways. What's the cleanest way? You have to use logs, yes, that's correct. What's the cleanest way using logs? Yeah.
Add logarithm base 5 to both sides.
That's what my other class really liked to do. Log base 5 of 5 to the x plus 2 equals log base 5 of 7 to the x minus 2. That's correct.
Because all your class asked me what to do.
It turns into x plus 2 equals x minus 2 log base 5 of 7. That's correct. Now it's just what? Just
Ninja.
algebra. Ninja, that's right. Now it's just algebra. Very good. What did you learn in your year abroad? Ninja. That's right. Ponies! Yay! So we get x minus x log base. I added in log base 5 of 7.
Okay.
I took log base 5 of both sides. I took log base 5 of both sides. Equals negative 2 log base 5 of 7 minus 2. So that's x times 1 minus log base 5 of 7. And because I like factoring, negative 2 times 1 plus log base of 7. So what does x equal? Negative 2 times 1 plus log base 5 of 7. And as I finish this, you have to answer the question, do you think this is the way I do it? Meaning me, the teacher? No, I actually am hard-coded to do something else. Anybody want to guess what I'm hard-coded to do? Meaning I just do it by default and go with it?
Natural log.
Natural log. I am totally hard-coded to use natural log. So if I use natural log, I like it because it's less to write and I can do it faster. ln 5 to the x plus 2 equals ln of 7 to the x minus 2, which means that x plus 2 ln 5 is equal to x minus 2 ln 7. Now it's just algebra. Now we are at, right? So now it's x ln 5 plus 2 ln 5 equals x ln 7 minus 2 ln 7, right? So that's x ln 5 minus x ln 7 equals negative 2 ln 5 minus 2 ln 7. So that's x ln 5 minus ln 7 equals negative 2 times ln 5 plus ln 7. So that's x is equal to negative 2 times ln 5 plus ln 7 all over ln 5 minus ln 7. Now, can you rewrite that a little bit differently? Sure. You have ln 5 plus 7. What is ln 5 plus ln 7?
ln 5 times 7.
35.
Both of what you... Both, correct. Same thing. Very good.
I thought that natural
So that'd be
log
negative.
was for log base c.
It is log base c. That's correct.
So,
You can choose any base you want. And what could you turn this into?
5, 7.
Yeah, it's debatable which one is more simple.
So there's much less first in my way.
Which way? The first one?
Yeah.
Oh, I think so too. I just really like writing ln. I can write it physically. I can write it faster, and it's more automatic with me. I like using ln as my common obliteration tactic. Yes.
Obliteration tactic.
Yes. You like my vocabulary. That's right. Moving on. Any others from 37 through 56? No?
51? No, 52. Sure.
52?
I just want to see more.
Log base 10 of 7x minus 12 equals 2 log base 10 of x. What do you have to do first? Yeah. So if you just take that 2 and bring it up to this, now you have log base 10 of something equals log base 2 of something else, so therefore, so x squared minus 7x plus 12 is equal to 0. There's a factor. Does it factor?
Yes.
What's it factor into? So x is equal to 4 or 3. All done.
Wait.
So it took us basically a half a step to go. Now it's just algebra. I know there's no n in there. You're disappointed. To the 121st power, exactly. And then you divide that by 1 minus alpha r. Oops. Like that. So then you have to do 125,000 divided by that. Boom. There it is.
Okay. What?
So that number next to it, this whole thing right here, This whole thing turned into about 148 point something. And A turned out to be, where is it? Right there. So then you can answer cool questions like how much interest are you earning over the course of the loan or the course of the generating this amount of money? How would you figure out how much interest you're earning? By what?
The number of payments that you make.
Exactly, and then you subtract it from 125,000. Very good. So you end up earning $24,153 in interest. It's pretty cool. Yeah.
I just want to make sure that whenever we store something, I know we always store it by alpha and then a letter.
Yes.
But that the letters in alpha do not have any like number meaning.
Not unless it's already stored as something.
Okay, so
By default, they do not. No. And you can store it as double letters, too. You can store it as a word. I think, as far as I know. Let me try, actually. Let me go back on that. Hold on.
Stored as Danilo.
Ready? Danilo. I don't really want to type it. Ready? D-A...
use second alpha.
Yeah, alpha lock.
Yeah.
There you go. Ready? That's not what I meant. Yeah, you can't. It doesn't like it.
Damn.
Well, was it this class that came up with the Wolfram Alpha observation? Remember when we looked at Wolfram Alpha a couple months ago and asked you guys to find some interesting things about it? Did I tell you what one of the other classes found?
No.
Ready? And we are... What? Factor. Yeah, it's pretty easy to factor. What do you factor the bottom into? Factor out x, and you end up with 1 minus. But what's that equal? 1 minus x times... Like that, right? Are we done simplifying? No, we're not. What do we need to do, Feria? Yeah, if you factor out, like factor out a -1 there, it becomes -1 minus x. We haven't changed anything, we just factored it. Why did I do that? Now you can cancel, right? So actually there's a removable discontinuity at x equals 1. We haven't changed anything. I just factored out a -1. So what does that tell us? What's the vertical, where are the vertical asymptotes? And no, -1 and x equals 0. Any other asymptotes? Simplified. What's the degree of, so what did this simplify to? -1 over x times 1 plus x. What's the degree of the top?
No, there's no.
Yeah, there is. 0 is the degree. What's the degree of the bottom? 2. It's a quadratic. This is a quadratic, power 2, right? So the degree of the bottom is greater than the degree of the top, so it has a horizontal asymptote at what? 0. If the degrees were equal, then you look at the leading coefficients. They're not equal, so you don't look at the leading coefficients. So there are your asymptotes. The biggest mistake on this is people do not simplify far enough. They do not simplify.
And we found 0. Alright.
If it's great, if it's one, if the bottom's one greater than
If the bottom is greater at all, it's always y equals 0, no matter what. Yeah, sorry. You're also next to the heat generator right there. Hold on, one at a time. Wait, 1 second. Okay, any O's from 35 to 46? Want to do it? Okay, you asked about 37. We'll do 37. 37's fun. I like this one. I hadn't seen one like this in a
So
while.
does that mean that, okay, can I ask you a
So,
question
let me
about
write it down first. Yeah, go ahead. Sure.
So if you've got x to the 4th, you need to simplify that.
Oh, you always need to start by
Right,
trying to
right.
factor. That's correct.
So you're going to factor it, but does that mean that the numerator's multiplicity is still 4?
Yes. No, multiplicity. You never look at the
Or,
multiplicity of the numerator.
No,
Multiplicity is only in the denominator.
Degree.
The degree of the top is always 4. That's correct. For
Okay.
this one, yes.
You threw me off.
But for here, for asymptotes, what are we really interested in trying to factor?
The bottom.
The bottom, right? You try this, can you factor it nicely? No. How do you verify you can't factor it nicely? No, just look at b squared minus 4ac. That's going to be -1 squared minus 4 times 1 times 1, which is? That means there are no real solutions. So are there any nice factorizations of this? No, there are none. So nothing cancels at the top nicely, right? So first of all, are there any vertical asymptotes? No, because there's nothing that makes the denominator 0. What about horizontal asymptotes? No. What about oblique asymptotes? The only time oblique happens is if the degree of the top is 1 greater than the degree of the bottom. Is that true here? Nope. What about horizontal? Nope. This has no asymptotes, no linear asymptotes. As a side thing here, if you graph this on your calculator, you will verify it has no asymptotes. It'll look a lot like a... Brooke, what it'll look like? It looks a lot like a parabola. Let's figure out which parabola it looks like. How did we find oblique asymptotes?
And we solve into the quadratic and then find the root.
You can. That would find just the zeros, but zeros aren't necessarily asymptotes, right? In this case, the top has no real solutions. It never crosses the x-axis. This has no asymptotes, and it only has a y-intercept.
Oh.
So in this case, how do you find oblique asymptotes? What process do we use? We don't use synthetic. We can't use synthetic here. Polynomial long division. Yeah. So let's actually do, all this allows us to do is rewrite it in a different form. You notice the zeros I'm putting in?
Yep.
Leading over leading, what's the first one going to be?
X squared.
X to the fourth over x squared.
Wait,
Leaves
and
you
how
with-
do you know you have to stick it there?
Because it's over the x squared.
Oh.
So then you get x to the fourth. You have to multiply by all three things there. Watch. So you get x that minus x cubed plus, and then what do you do? Yes, the whole thing. So you end up with what? Nope. Positive x cubed plus plus x squared.
This is just simple division.
0 over 0, x cubed. 2 minus 1 is 1, so that's why it's just x squared. So what do you end up with up here? Oops. What do you end up with? Plus what? Plus x, that's correct. Now you multiply, and what do you get? X cubed minus x squared plus x. You can bring that 0x down right there. Now you subtract again, what are you left with? 2x squared. That's it, right? Minus x, thank you. Plus 1. Now what do you put up here? Plus 2. 2 times that is 2x squared minus 2x plus 2. Subtract, and you're left with x minus 1. Do you go any further? No, so this thing's going to be x minus 1 over x squared minus x plus 1. Now here's the thing. This is just a rearrangement. We found a different form. What this is, and up until today, I'd never written this in class. This you would call this, I'm giving it a term here, a parabolic asymptote. This is what the function approximates. As x gets huge, this piece right here, what does this go to? Goes to 0 because it's, look, x squared is going to get huge. X doesn't get very big compared to x squared. So as x gets huge, what's the only thing that matters? This part right here. So if I go over back to my graph, it's x squared plus x plus 2. So what was the original function? Hold on, I got to pause it. We already established that that has no real solutions right there. So what's the only vertical asymptote?
1.
Yep, x equals 1, exactly. Are there any other asymptotes? HA or OA? Either one? No. The degree of the top is 2 greater. So again, what kind of asymptote would this have? Parabolic, yeah. Yeah.
Can you quickly explain the synthetic division?
Sure. These are the leading coefficients right here.
Yeah.
This is the potential rational 0. And then you drop it down, you multiply by this number, you add them, multiply by that number, add, multiply, add. In this case, what are we multiplying repeatedly by? 1.
Wait, you add by, you multiply by the rational.
By the potential rational 0 on the diagonal, yes.
Okay.
You use this is synthetic division.
Right.
All synthetic division essentially does is this. All synthetic division does is evaluate a polynomial. What does this polynomial evaluate to when we plug in 1? It evaluates to 0. When you plug in a number and a polynomial comes out to 0, that means that that number is a 0. But anytime anything is a 0, it corresponds to a factor. If you know a 0, you have a factor. If you have a factor, you know a 0. All synthetic division does is allow you to evaluate polynomials. We're particularly interested in it when it evaluates to 0 because that gives us a factor. But is it also useful just for evaluating polynomials?
Yeah.
Sure. If you have a polynomial, seriously, watch. Let's say it's a stupid polynomial like 2x to the 9th minus 4x to the 4th plus 3x squared minus 15. It's going to get big, but let's say we want to evaluate that at x equals 2. How could you do that? What are the coefficients?
No 0, 0.
8, 7, 6, 5, 4, 3, 2, 1. Those are the coefficients. And what am I evaluating it at? 2. Ready? Drop this down. Start here. 2 times 2 is 4. 8. Does it get big pretty quick? Did we expect it to get pretty big? What? No, we're adding. We add here. So 240. What? Oh, sorry. Excuse me. What is it? 972 minus 15 is? So if you plug in 2, if this is f of x right here, we just found out that f of 2 is what? In the context of what we've been doing is that... Well, let's not do it because there's no point right now. If you plug in 2, you end up with 957. That hasn't been very useful to us because it's not a factor. We've been using this for its byproduct of showing us factors. But is it still useful? Sure. Is this something you could do if you got bored? Sure. Oh, fun! That's great! I want to stay in school the rest of my life because of this. And with that, I pause. Denominator. In this case, you'll end up with 2 times sine x minus 1 minus 5 times sine x over sine x times sine x minus 1, which turns into negative 3 sine x minus 2 over sine x times... So does that match one of the answers? C. It does. The third one. Now, we're going to have a little contest here. It's not the right answer is not the contest, because I know all of you know the right answer is 9. It's 9. I just killed the hopes and dreams of students everywhere. Yep. And I think, yeah, that was recorded. Good. Okay, what are we multiplying by in order to... What's the quickest thing we can do? Multiply by what? 6n. If you multiply by 6n, I heard it over there, I was verifying, what do you get? 30. No, everybody, for the video, you need the context of his statement. He wants to, do something with his future, so when you dig up this video and audio later, don't hold it against him. Minus what? 3n equals what? 3. So it turns into 27 is equal to 3n, so n is equal to 9.
Okay, that was in here.
Wait.
Yes, it is. That is the cleanest way possible. Get rid of the denominators. Who made this harder than it was?
I did.
No!
I ended up doing something with...
Wait, yeah, you did.
How did you use it for the simplification?
Can you...
6 times 5 is...
30?
N over n is... It cancels.
Oh, okay.
6n times a half is...
6n over
6n times 3 over 6n is... 3.
Yep,
Done.
Got it.
Get rid of the denominators. Kill it. Get it out of there. Okay, 4. 4 is really fun. Yes, it is. You have a calculator, the magical device that can tell you anything. You just have to know what question to ask it. Well, you definitely know how to do this. How do you find the intersection of two things using your calculator? Yeah, you intersect at this and this, and you find out where they intersect. When you graph this, 3 cosine 2x, right? And then you have cosine x plus 2. My window is going to go from 0 to 360. It's a little too high, isn't it? But you get the idea here, ready? So it's going like that. How many times does it look like it intersects?
4 times.
Looks like it intersects 4 times. The scale's pretty bad, but I actually like this because I can clip it in. It tells us that there are 4 answers because these two functions intersect apparently 4 times. Here, 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 and here. What can your calculator tell you? Where it intersects. You use the intersect function. So if you do that out, it does come out to 0, 360, and 2 more here. Now here's the thing. What can you tell me about that picture right here? I mean, this graph does go down like this.
It looks like a sombrero.
It does, but in terms of shape, what does it look like? It's symmetric. These answers look symmetric, therefore that gives you a strong hint that this is solvable. When you see symmetry like this, there might be a solution method, and there is. We're going to do it in the next few minutes. The entire solution method, though, revolves around knowing what? What's the key to knowing the solution to this? Addition of cosine.
Is it like cosine alpha?
Exactly, and I'll just tell you what it is. I don't remember it. The only reason I remember is I've done it twice already today. This is what I look up. Cosine of x plus y is equal to cosine x cosine y minus... Yeah, you had to. Some of that pointless stuff you learned in high school, right? Right? Now here's the thing. If x and y are the same, cosine of 2x is the same thing as cosine of x plus x, right? So that's cosine squared x minus sine squared x. To suit this for what we want, cosine is on this side, so we want to write everything in terms of cosine. What is sine squared? 1 minus cosine squared x, right? So you take that, plug it in there, so you end up with cosine squared x minus 1 minus cosine squared x. What does that equal? 2 cosine squared x minus 1. So now when you plug this in right here, you get 3 times 2 cosine squared x minus 1 equals cosine x, is it minus 1? Plus 2, thank you. Now it's just algebra. It looks like it's super hard, but it actually falls out really nicely. Just watch. We don't have much time, so I want to finish this while you're here. Why did I make it equal 0? Quadratic. What's your favorite letter?
T.
T is equal to cosine squared x. So 6.
No, it's cosine X.
Ah, thank you. Cosine x. Thank you. This is that quadratic fakery we've done before.
Yeah.
Does that factor? It does. What does it factor into? Minus 5. Close. Switch the signs. Look, because it has to be negative plus 5 right there. So what does that tell us? 6t plus 5 equals 0, or what? But t is what? 6 cosine x plus 5 is equal to 0, or cosine x minus 1 is equal to 0. So cosine x is equal to 1. How do you solve that? What button would you need in a calculator? Yeah, you need x equals cosine inverse of 1. Can someone tell me what the cosine inverse of 1 is? Don't use your calculator. This is actually one of the few you actually should know. It's 0. The cosine, this says the cosine of what is 1? 0 and what? 360. So in this case, x is equal to 0 and? Does that match our graph? Yeah, it does. Cool, huh? Now we can actually get the exact values. This is going to be cosine x is equal to, so in this case, x is equal to cosine inverse of. If you do that out on your calculator, it's not one. It's not a nice one. 140 something degrees. Right. Now here's the thing. How do you find the other one? What'd you say, Faria? You got it right there. Perfect. Yeah. You can do that because look at the graph here. If you do this out, this is 180 right here. It's symmetric over at 180. You also know that, you also know this. Cosine of alpha is equal to cosine of 180 minus alpha. Remember those identities you did? The symmetries that happen? Ring some bells? I'm just, yeah, you're like, ah! So what is the other answer? 180 minus, oops, that was not it.
We need to know the addition identity.
No, you do not. I was just showing you how you could do this one. Oh, it's plus. I'm sorry. It's that distance. Now we add 180 to it, right? 213 is the answer. There it is. So we actually found out all these answers. You could use the intersect function, but is the intersect function super accurate? It's okay. It's really good. Yeah, I like knowing exactly where they come from. But here, what's the lucky thing about this whole process here? It's symmetric, which is really nice, which gave us the key that made us think it might be doable. But what do we see right there? We got to here, right? Is that necessarily something we would be able to solve this nicely? No. The fact that this is factorable is really, nicely factorable. This is nicely factorable. The fact that it's nicely factorable, is that guaranteed? No. No, it's not. Could it have easily been like some irrational, weird, like 1 plus root 2 over 12? Yes. Sure. Absolutely. This was doable by hand. So on a multiple choice question, the answer could have been x is equal to cosine inverse of negative 5/6. You know, is that one of the answers? And you'd be like, ooh, don't know. But now you know. Yes?
So do we use the graphing method as a solution?
All this question is asking you, number 5, all it's asking you to do is plug stuff in. That's it. Do you have any ability to deal with curvature? Do you have any ability to deal with anything super complicated? No, like know your limitations. I looked at this and I was like, Smallest angle. You will do a whole bunch of stuff, Danilo, later in in calculus, where you have to find things like smallest, fastest, steepest, shallowest. Do you have the capability of doing that in this class? No, that is calculus. That is something else.
I had to